Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. May peace be upon us all. Shalom, Om Swastiastu, Namo Buddhaya, Good Secrets. Allow me to introduce myself. My name is Yotam Stefanidya. Through the Borobudur International Symposium, I would like to present the result of our research. Our research is design development of rocket stove with computational fluid dynamics or CFD simulation. First, allow me to introduce my research team member. Myself, Yotam Stefanditya. I am lecturer at Polytechnic Admi Surakarta. I've been teaching at this institution about 6 years old, and my focus in mechanical design engineering. Second, Felicia Maya Puspita. She is operation manager at PT Admi Bisdek. Next, Mr. Agus Kurniawan, lecturer at Polytechnic Admi Surakarta. And the last, Mr. Bayu Prabandono, lecturer at Polytechnic Admi Surakarta. Next, I would like to explain our background research. The traditional wood stove, which in Japanese society is known as pawon, usually made of stone, brick, etc., with a hole in the front of firewood input. The thermal efficiency of traditional wood stove is only about 15%, and air pollution due to the used wood stove reached 31.23%. Recently, to improve efficiency, many traditional stoves have been developed and are known as the improved coke stove. One of the popular improved coke stove design is rocket stove. The rocket stove has an elbow or G-elbow shape. This shape makes the user more familiar to operate the stove. The rocket stove itself has undergone many developments. However, the design of the rocket stove only adapts in terms of shape without taking into account the design principle for wood-burning cookstove, like the picture shown in my presentation. The design process of cookstove has evolved significantly, from trial and error becoming simulation analysis, such as finite element analysis and computational fluid dynamics. So, what is computational fluid dynamics? Computational fluid dynamics is an analytical method that produces quantitative prediction of fluid flow phenomena. CFD analysis is able to carry out simulation and produce prediction of fluid flow and heat transfer that occur inside the stove. With various changing parameters, this allows experiments to be carried out with various parameters to obtain the most optimal wood stove design. And now I would like to present the method of research. In this research, we developed design one of existing rocket stove made of steel material with thickness of 2.3 mm and has inclined chimney as a firewood input. To develop the design of this rocket stove, we using product development method described in the book Engineering Design: A Systematic Approach by Gerald Paul and Wolfgang Page. The product development process consists of 3 steps. First step is planning and task clarification. Second step is conceptual design. And the last is embodiment design. In the embodiment design step, we will get the most suitable design result. This design result we would like to analyze using computational fluid dynamics simulation. To run the simulation, we use the SolidWorks flow simulation software. CFD simulation is used to predict the heat transfer in the developed rocket stove design. Now we will present the result of our research. First step of product development is planning and task clarification. We identify development needs that are necessary on existing rocket stove by referring to the book design principle for wood-burning cookstove. And the results show that the principle of insulation is not owned by the existing rocket stove. And also, it doesn't take into account the size of the size gap. The next stage is conceptual design. After knowing the insulation on the rocket stove need to be developed, we're looking for what kind of insulation are more suitable. Various insulation options are assessed from technical and also economics needs. The results of the assessment show that alternative insulation made from ceramic fiber has been selected. At embodiment design step, we create alternative options that have been previously selected into a CAD 3D design. Insulation with ceramic fiber material is added around the outer wall of the stove combustion chamber. The thickness of the insulation itself is 30 mm, adjusting the thickness of finished material on the market. And we also changed the design of the existing port skirt. CFD simulation or computational fluid dynamics were run on the initial design and the modified design to see if there was an impact to performance stuff. The assumption we use in this simulation, we simplify the combustion process into a stream of a hot air. A hot air flows from the inlet to the combustion chamber, passes through a heat source with temperature 700 degrees Celsius and flow out forward. Boundary conditions that were run in this simulation could be read on the table. The result of the CFD simulation are visualization of the heat distribution that occurs in the stove. Warm and hot areas are marked in orange and red, and areas with low temperatures are marked with green to blue. To see the value in this simulation, we take 5 sections on the stove and measure the temperature, starting from the upper surface of the flame, the lower, middle, and upper chimney and area under the pan. And here is the value of average temperature at each section on initial and modified design. As we see, the modified rocket stove has hotter temperature since the combustion area and the result can conduct heat better. And now we will present the result of our research. Conclusion. According to the research that has been done, it can be concluded the design development of rocket stove by adding insulation made of ceramic fiber with a thickness of 30 mm surrounds the outer wall of combustion chamber of the stove and fixing the port skid can improve the stove performance. Computational fluid dynamics simulations show that modified stove can increase stove performance up to 11.15%. Thank you for watching our presentation. If you have any question, please ask through Borobudur International Symposium in Q&A forum. See you again in the next symposium.